Good morning, good afternoon, good evening, ladies and gentlemen, wherever you are in the world. This is Tim Collins, Secretary General of World Stainless, and we're now going to start the webinar broadcast. So I hope you're all sitting comfortably. A few housekeeping type issues before we start with the presentation. So there is no need to ask if you will get a copy of the presentation. That will be shared with all attendees after the presentations have been completed. So that's a question you don't need to pitch. Regarding questions, though, I'm going to be talking for about 45 minutes, leaving some time for questions at the end. Could you please pitch if you have questions, those questions via the chat function? Let me get my words right on this broadcast, and then we can at least amalgamate questions with similar themes or similar topics, and that will speed up the Q&A process. So I hope that's all clear, and I'll now get on and start with the presentation. So first up, the agenda, but before I do, can I just check, Joe, is the sound okay?
Yes, the sound is fine, Tim.
Sound is good. Okay, that's great. Thank you. So today, I'm going to launch with a short introduction just to try and sort of put a few things into people's heads, then look at a timeline of key structures. And this is an illustration over approaching 100 years of the use of stainless steel in structures. And then we'll talk about why would you select stainless steels for this sort of or range of applications. Then I'll have a short section looking at some concerns that people do raise when thinking about stainless steels. Then we'll go a little bit controversial and talk about modern thinking, which might seem a little crazy, but I think applies in this context. Then I'll sum up at the end, and then we have chance for questions. So that's today's agenda. And moving forward to sort of introduce and set the scene, stainless steels have actually been used in structures for quite a long time, approaching 100 years. And the early uses were primarily associated with building cladding applications, and I'll illustrate some of those shortly. But what's interesting is that in the following decade, the 1930s, the stainless steel portfolio of different material grades grew quite considerably and continued to grow after that. And then in the following decade, the 1940s, we really started to see the use of stainless steel structural products in the built environment, albeit at a very low level. And today we have more than 200 different stainless steel grades available for choice and selection. But having sort of considered all those changes, whether they be to do with the use of stainless steel and the variety that is available, stainless steels are still a misunderstood family of products, particularly in the built environment. We're used to seeing stainless steels in our kitchens, in swimming pool environments, as claddings for things like lifts and facades. Even within museums, we see these things and we recognize them. Street furniture is another popular use. But do we actually understand what types of stainless steels are suitable for each application? Because they're not all the same. So we'll focus on the built environment today, but I think everybody should take that note that stainless steels are misunderstood and there is work to do to educate people. So following on from that brief first slide of the introduction, I think from the 1960s, it's fair to say that more innovative uses of stainless steels for structural applications and structural components really emerged. Whilst there was some early use in the 1940s, it's from the 60s where things started to change, and then a further ramp up came from the 1990s. But having said all that, and the steel usage in the built environment is large, to global level around 900 million tonnes per annum, only 1% of that is stainless. And that's an interesting comparison, particularly when you see the problems that occur that we remember that make the news in terms of bridges collapsing, buildings falling down. And often in those cases, there is a high corrosive issue going on there. And stainless steel deals with some of these things. It deals with corrosion resistance quite effectively. We're probably all familiar with that, but there are so many different types of stainless steels and so many different types of corrosion mechanisms. Are we pairing things properly? That's one question. Stainless steels have high strength, and not everybody is aware of that. There are a family of stainless steels that offer very high strength and better than some structural steels. So, again, these products should be considered. And also, when you're dealing with high strength corrosion resistant materials, you can reduce the quantity of other materials in structures, the co-materials. And all these things together bring a future maintenance reduction ability. And that's going to be one of my questions later on. The notion of maintenance, why do we want to maintain things when we can minimize or avoid maintenance? And when you start to put all these things together, the notion of appropriate materials bringing structural sustainability, I think, is an important prize that we should be striving for as a community. And all this leads to stainless steels being one of the major materials that has a high contribution to the circular economy. Somewhere between 95 and 96% of end of life stainless steels are recycled. And there's only other steels that could become comparable to that. Aluminium, ceramics, glasses, plastics, and polymers, their recycling credentials are all weaker. And whilst the metals are generally the best group, there's only steel and stainless steels that have these very high capture and recycling rates. I think it's also fair to say that stainless steels, when you're working with them, require different processing knowledge. They are not hard to work with, they're different. And if you want to work with stainless steels, you just have to learn some different techniques. They're different, as I said, to other steels, to other metals and alloys, but not hard. So let's now sort of start to set the scene a little further with looking at a timeline of key structures. And this is going to be illustrated over two slides with some images as well. And I'd first like to start by going from the 1920s to the 1970s. And there are a few interesting thumbnails there. Some of those structures you may well know already. But in the 1920s, the Savoy Hotel in London in the UK is a very famous structure. The entrance, foyer, and canopy, it uses stainless steel cladding. It's survived very well up to the present day, just gets regular water cleaning, nothing complicated, and still looks pristine in a busy urban area. As we then move into the 1930s, people will be very familiar with the Chrysler building in the USA. The Chrysler building sort of opened in the early 1930s, so it's approaching 100 years old. And what's interesting here is the stainless steel cladding that looks pristine and still very attractive. Has only been cleaned 3 times in its entire life with a basic household detergent. But because people back in the 1930s were not sure how long stainless steel was going to last for, 2 sets of this cladding were actually made. And it's only a few years ago that that second set, which had never been used, was actually sent for recycling. So I think that's a sort of interesting sort of perception of how people looked at stainless at that time, almost 100 years ago. They weren't sure. We know so much more now. Moving forward to the 40s, and I think this is a classic case that some people will know and many people perhaps don't know. The Progreso Pier in Mexico is the long, very attractive looking pier to the top right hand side of this image. And this was built with stainless steel reinforcing bar in the early 40s. It was opened. The remnants of a pier that you can see to the left of that was actually built in 1969 with carbon steel reinforcing bar. And it didn't last very long, which is really interesting. So this is a great example of understand your corrosion mechanisms to choose the right material to give you structural longevity. And if you don't start with that basic sort of level of interest, questioning, and understanding, you're likely to choose the wrong materials. So rolling forward into the 1950s, Lever House in the USA is an interesting case because originally when it was built, stainless steel was used as cladding for the structural components down at ground floor level. So protecting those structural steels and other materials with stainless. But actually, over time, additional stainless was added, particularly in 2001, to improve the resilience of the structure. So this is a great example of a building having some stainless applied to deliver structural longevity, but then further being enhanced in later years. And it's not, I wouldn't say, a classic or impressive structure like the Chrysler building, but it's a very good example of thinking how to protect your structural components. If we then move forward into the 1960s, we have the Thyssen in Germany, which is primarily a clad structure. It uses some aluminium and a lot of stainless. So this is 304 grade stainless at 18% chromium, 8% nickel, 1.5 millimeter thick cladding, and it's just water washed twice per year to maintain its impressive appearance. So this is a nice example of thinking how to employ stainless to good effect to protect the exterior of the building, to have a low maintenance requirement. And then the next case, Bush Lane House in London in the UK, and this is very innovative, and I will talk a bit more about this later in the presentation. But what's apparent when you look at this structure is the exoskeleton around the building. And this building had to be limited in height because of protected viewing of other impressive structures in London. And I'll talk about this a little later, as I've said. But the creation of the exoskeleton removed any need for internal columns, thereby freeing up space on the 8 floors of the building. So this is a very interesting case. Now let's jump forward. I'm now going to move through the 1980s up to the present day. And what you will see now is more structures in this sort of timeline of key structures. We have the Thames Barrier in the UK, built in the early 80s, still looks perfect today. And the Sun Life Centre in Canada. This is another example of a clad structure, again, 1.5 millimeters thick, 304 stainless steel, but also some structural cladding as well on the inside around the structural steels, which is less thick. It's 0.8 of a millimeter thick, and all the fixings used here are stainless too, which is an important consideration. And again, simple cleaning regimes. The outside of the building is just cleaned in totality when the windows are clean. It doesn't require much effort. Then moving on to the 1990s, we have the Schaffhausen Bridge in Switzerland, which is going to come up as a bit of a case study a little later, but also the Petronas Twin Towers in Kuala Lumpur, who most people will be familiar with. And these are a very impressive pairing of buildings. And this heavily uses stainless steel structural components that are extruded parts. So a different approach to making the structural components, but a strong use of stainless steel. Also added to this, because this is a very hot, sunny environment, stainless steel visors have been applied to all the windows to allow people working in this environment to not get uncomfortably hot or blinded. So there's some quite innovative use of stainless steel in the Twin Towers. As we jump forward to the early 2000s, we now have the Flood Control Centre, which is a series of buildings in the Netherlands using extensively stainless steel, and the Parliament Domes in India, but also the Atomium in Brussels. And many people will be familiar with the Atomium from the World Fair in 1958. Originally, these balls were clad in aluminium. They were replaced in 2006 with stainless, and that bright finish will resist corrosion, look really impressive in the skyline, and reflect the space around. It gives a very impressive appearance wherever the sunlight is in the day, and if it's not so sunny, you still get different reflections. So if this is a smart use of stainless to primarily replace aluminium that doesn't benefit from the same degree of longevity. As we move into the 2010s, there's a few important structures here. So we have the Haneda Airport extension in Tokyo, built over the sea, which I'll talk a little bit about later, the Rose Museum in China, and the Hong Kong Zhuhai Macau Bridge, which is shown in the thumbnail. But what I want to sort of illustrate here is the Rose Museum in China, which is an external um, sort of artistic structure, I think is probably the best way of explaining this, that protects the inside of the museum but looks stunning at the same time. And from the perspective of a designer's point of view, this is a very smart use of stainless, because this is just not a thin structure. You can see if you look into the rose detail that it's actually quite a thick structure, but it's all made from stainless flat products. So it's very impressive and it's a novel use of stainless. And moving up to date, people will recognise in the thumbnail the St George Bridge in Italy, which has replaced the bridge that sadly collapsed a few years ago. And you'll see in the thumbnail that there is a use of stainless steel reinforcement. It's what I'd call selective use, so it's not everywhere and it doesn't need to be everywhere. You don't have to replace all your structural steels with stainless. This notion of selective use is smart thinking, and I'll come back to that again a little later. You have the Queen's Cliff Ferry Terminal in Australia, which I'll illustrate in a moment, and also the Avon Modular Footbridge in the UK, which is a full stainless steel bridge, bolted together, no welding, and that brings a huge number of benefits that I'll talk when I illustrate that bridge later. But here's the image of the Queen's Cliff Ferry Terminal. And this is quite impressive because even though you can't see the sea from this image, you can see the stainless steel on the roof space and some of the areas below. But this was a particularly challenging environment. So the selection of the stainless grade was particularly important to resist what's known as pitting corrosion. And this grade does exactly that. As well as this being beautiful, it's absolutely functional and should last a good 120 years. So if we move forward, having sort of given some nice illustrations there, why would we select stainless steels? And I'll start with myths. And this is not the full list of myths. These are the ones that are probably the most popular. Lots of people have said to me, hey, the industry only makes two grades, 304 and 316. That's all there is. Well, there aren't. And you've already heard earlier, there are more than 200 different grades today. Do we promote them enough? Probably not. So there's work to do there. Stainless steels, second myth, stainless steels do not offer the strength needed, particularly in structural applications. And that's nonsense in itself, because we have high strength stainless steels and we have done for a long time. They are an important part of the portfolio. But again, we need to educate people, get the sort of concepts out there so they understand. Bit of a strange one, the next one. Stainless steels are non-magnetic. Well, 3 out of the 4 primary families of stainless steels are magnetic to different degrees, but some stainless steels are non-magnetic and quite a lot of stainless steels are magnetic. It's not really important for today's webinar as such, but it's just interesting what people think about and the notions that stick in people's heads. Following on from that, all stainless steels are the same. So many people have said that to me over the years. But we have lots of stainless steels and they all have different properties. They all deal with different corrosive environments. So they're not all the same. They're very different. It's like horses. If you have a horse that runs on a flat course, that same horse would probably not be so good at jumping over hurdles, and vice versa. Stainless steels are a bit like that. They have different properties, different benefits. The next one, stainless steels don't rust. Well, I think the important thing here is to look at the word. It's stainless, not stain not. So if you understand corrosion, then you can choose the right stainless steel. But if you don't think about corrosion, then you won't necessarily choose the right stainless steel, and you probably will choose the wrong steel as well. And we've got great examples of that, of things that have failed. Stainless steels are expensive. The third myth. Well, they are. It's not really a myth, but how you use them is what is the game changer. So I'll discuss that a little later in the presentation. So let's move on and say, let's look at the grade families now. And I'm not going to spend several minutes talking about all of these elements in the families. There are four broad families. Austenitic stainless steels, primarily used for kitchen equipment, food processing, chemical process plant. There's ferritic grades, also used for cladding and kitchen equipment and automotive applications. The duplex family, and this is where the structural products really come into their own, and fixings, materials, and products for nasty environments like the oil and gas industry. And also the Martensitic family, where you'll have cutting equipment, surgical instruments, valves and gears, etc. So we've got a huge range of properties to draw on. But I think what's interesting when you're thinking about structures, and the duplex family become really important, that what you've got here is very high strength materials with reasonable ductility, and they remain ductile down to somewhere between -40 and -50 centigrade. So this is a good product family to think about from a structural applications perspective. Now, I'd like to start to address the cost issue, but I would argue that stainless steels are an economical material, but they're discounted because of their cost. You're going to pay at least 2.5 times that of a low alloy steel typically, and sometimes more. But the advantages that stainless steels bring allow you to rebalance the pricing considerations. So the high strength offered by duplex grades allows for an overall materials reduction. An example being, you can use, in the case of reinforcement, somewhere greater than 20% less concrete. And that adds to the overall reduction in cost. So you pay a little more for the stainless, but you take something away. Also, when you're thinking about using stainless, when you use it appropriately, you prevent structural degradation. So maintenance costs fall. And I'll come back to maintenance a little later. And then when you think deeper about stainless, you can start to redesign things to give enhanced operation and actually reduce the amount of materials in totality, including the stainless steel. So there's lots of opportunities. Now, I'd like to illustrate this with a couple of waterfall diagrams. This is based on a case study of a large bridge in the UK. The bridge was actually built according to the chart on the right, the large bridge with 10% stainless steel structurals for the deck. This is a big bridge, around 2 kilometers in length. The chart on the left, sorry, the chart on the right is how it was built. Let me get my words right. The chart on the left is how the cost profile would look had you not used stainless steel structural components. What's interesting when you look at this is that the green block that dominates this, the fabrication and installation cost, is the biggest element. Materials is relatively small, whether it's with stainless or without, you pay a little more. But when you get to maintenance, then there's a huge difference. So the maintenance cost is somewhere lower each time you have to undertake maintenance. The amount of maintenance increases over the life of the bridge. But over the course of about 100 years, you'd save in excess of 100 million euros for a sizable structure. And that's not to be sort of underestimated. So there are large savings to be had, but we have to think in a different way. We have to think about using stainless in an appropriate way for the environment. You can control the upfront costs there to be within 1 or 2% of not using stainless, sometimes less, and I'll come on to an example that's less. But then look at the maintenance benefits you get. Maintenance is not something that should be expected. It's something we can minimize or avoid. If you then go on and look at life cycle emissions for the same bridge, same example, then you see an even bigger difference. And if you have to undertake a lot of maintenance, you are creating emissions during that maintenance work. Everybody today is looking at the emissions associated with producing materials. there's nothing wrong with that. But very few people are saying, hey, when I get to use this building, structure, whatever, what's going on from an emissions perspective there? And as time progresses, if you don't use resilient materials, maintenance becomes the dominant emissions activity. So I think we're at the point where we should think to change our materials mix, because you can have a massive impact on emissions if you don't undertake as much maintenance. In this section, I'd also like to talk about corrosion, because corrosion is something that's pretty misunderstood. Now, stainless steels are corrosive resistant, as many people will know, due to the invisible passive layer on the surface, which is self-repairing in the presence of oxygen. But we also have available in the sort of steel products range coated steel products, whether it be galvanized, epoxy coated, just painted. But coatings fail. They always fail and create repair challenges, particularly if you're dealing with steel products that are hidden. So if you're going to hide your steel products inside concrete, then you should know what's likely to make it corrode. And there's 11 common forms of metallic corrosion, and you need to understand at least several of the common ones. But if you know what forms of corrosion will be present in your environment and how it can attack your materials, then you can choose the right materials, and particularly the stainless steel grades that will give the protection. And we're talking about choice of the right grade in the right location within a structure. And then you can take this notion of selective use of stainless quite far. So you don't necessarily have to, unless you're making structural components from stainless, have stainless reinforcement everywhere, for example. Now, to move on and illustrate that, I'm going to talk about four different types of corrosion. Pitting corrosion, which you'll illustrate a bit more on the next slide. If you're working in a marine environment above the snow line where de-icing salts are used, or in a setting where airborne chlorides, sulfur-bearing oxides, and things like that are present, you're likely to suffer from pitting corrosion, and you need to choose a grade that will prevent pitting corrosion. I'll illustrate that in a moment. Galvanic corrosion is another issue. If you've got different metals in contact, direct contact, and you've got some electrolyte present permanently or intermittently, you need to understand how galvanic corrosion is going to occur. And whilst people will say, hey, I can overcome this by sticking a an electrode on that's going to corrode first, a sacrificial electrode, that's useful in certain circumstances, but it prevents problems as well, because the sacrificial electrode is sacrificial. And once it's gone, if you don't replace it, other things will happen. But also, people overlook where galvanic corrosion subtly occurs around fixings and those sorts of jointings in sort of total built systems. So galvanic corrosion is not as straightforward as some people would have you think. Crevice corrosion is fairly common, particularly if you've got gaps in and contact areas between metallic material parts, and you get dirt buildup in there. You set up a little electrical cell that then causes corrosion of one of the materials in that area. So crevice corrosion can be avoided, and it can very easily be avoided, but you need to understand it. And intergranular corrosion should be considered if you're going to weld elements within your structure. And again, understanding how to work with that is important. World Stainless has lots of information on these types of corrosion. I'm going to illustrate two next, but you can get more information directly from us. So pitting corrosion, this is probably one of the biggest sort of hurtful types of corrosion, because it's often occurring when the steel's hidden. And what you've got here is a hierarchy of stainless steels primarily. But if you look to the bottom left-hand corner, carbon steel is really poor for resistance against pitting corrosion. And then you can see the stainless grades as you move diagonally across this chart. But I think there are two important thresholds. If your structure is going to get splashed by seawater, you need to choose grades that are above that line. And if you're immersed in seawater, you need to move up this hierarchy even more. And the pitting corrosion resistance is derived by a a formula related to the chemical analysis. It's very easy as a tool to follow. And I would argue if you're designing things in corrosive areas or areas where corrosion occurs, particularly with chloride, sulfur dioxide, and things like that, learn this chart or have it at your disposal. And then you can't go wrong choosing the right grades. But please don't expect a carbon steel, even something that is galvanized, to work perfectly in these environments. They won't. Galvanic corrosion is the other thing I wanted to illustrate, and I think many people will know. Two different metals in electrical contact with a conducting electrolyte will give the strong likelihood of galvanic corrosion, particularly if you've got what's called a noble metal in contact with a less noble metal. So stainless steels are generally noble. The duplex and austenitic grades are very noble, ferritic and martensitic less so. But the less noble materials that tend to corrode include zinc, aluminium, general steels, carbon and low alloy, brasses, and copper. And as long as these conditions are in place, the electrochemically dissimilar metals, if I can get my words right, the metals in contact with each other, so a current can flow, and an electrolyte present, which can just be simple water or some cleaning solutions, then when you've got these things, you need to be fully aware of galvanic corrosion. And it is easier, I would argue, to choose the right materials to avoid galvanic corrosion rather than rely on coatings or sacrificial electrodes to solve the problem, because these things don't work forever. So, an important aspect, galvanic corrosion, and there's appendices that cover this in a little more detail attached to this presentation. Now, one of the key benefits, which I'll sort of illustrate a little more as we go through this presentation, is the ability to reduce co-materials. So if you exploit the high strength of duplex stainless steels, you can reduce concrete. I've mentioned that already. And less concrete cover is needed because you're putting in a product that will resist corrosion, and particularly pitting corrosion. But also, when you start to think about employing stainless steels for structural components, you can also lightweight your whole structure. So you can bring down the total amount of materials, because when you're using stainless steels that are not just corrosion resistant but have high strength, better than that of some structural steels, then you get the lightweighting opportunity. And there's an example I'll illustrate a little later in this presentation. So in terms of summary, I think there's many good reasons why you should select stainless steels, why it should be part of your portfolio, because you've got a wide range of things to choose from in terms of grades and products. These materials are suitable. They're designed for corrosive environments, so don't overlook them. You can reduce your bill of materials quite sizably. You can deliver a reduced life cycle cost and lower your life cycle emissions. Let's think beyond the production emissions boundary. You can reduce your maintenance needs, which has to be good. We're all, I guess, sick and tired of seeing roadworks that delay our journeys to certain places, seeing facilities that don't work. We can eliminate those. And you can rethink your material choice and your manufacturing routes. And I'll come on to the notion of modular manufacturing in a little time. But ultimately, and I think should be the goal for all of us, we want long life structures. And when you're using stainless, these things look really appealing as well. You're not creating something that looks outdated very quickly. So let's move forward and address the concerns. So the cost of stainless, I've touched on this with the waterfall diagram and the fact that you get lower life cycle costs. And if you take maintenance away, which is particularly important in environments that are going to give you corrosion problems, then you start to save money. If you take your requirement for total materials away, you start to save money. If you don't have to replace things quickly, you clearly save money. If you reduce the amount of urban disruption because there's less maintenance, then other people benefit from that. Society benefits. And if you're working with a material that delivers lower emissions over the operational life, that's very, very good. And that they're hidden emissions almost. We don't talk about them very much, we don't see them, but they're a significant component of our total CO2 and other emissions into our atmosphere. So stainless does address a lot of concerns from a cost perspective. Now, the next couple of things are a little more less obvious. Many people have said to me over here, well, I've not chosen stainless because it's difficult to get the right products. And I think what you have to do is start with a different mindset. The stainless steel industry is about 4% of the size of the carbon and low alloy steel industry. So we're small. So because we're small, you need to think about sourcing differently. Mills and mills service centres can really help you. They will point you in the right direction. They'll tell you how to get hold of the products, the lead times, etc. Not all stainless products are off the shelf yet. So you have to plan in good time. Don't expect to pick up everything from a stockist in 48 hours. That shouldn't be a reason for not choosing stainless. It should be just driving a different thought process. And both World Stainless and the regional stainless steel associations are helpful resources. They will assist people who need support with sourcing materials. And we should exploit that. It's a good network. Now, the third concern is stainless steels are difficult to fabricate. And I said early on in this presentation, it's different, not difficult. And steels do need different treatment, often in fabrication. But it's a skill set you have to learn. It's a different set of rules. And when we think also there are different ways of doing things, structural components can now be produced through automated routes. So laser cutting and brake press forming of stainless steel sheet and plate can produce structural components very quickly. And that allows for a bill of material standardization, which helps a dramatic number of things. And again, we come back to the stainless steel development associations. These people run practical education courses for your fabrication processes. They're out there to help, and it's worth checking who's doing what and signing up for these courses. You'll learn some useful skills, some good knowledge, and that's all positive. And World Stainless can also help you with your sort of nearest contact your nearest association. Now, moving forward, I like to think about stainless steels, designing and specifying them. And people say, hey, this is not always easy either. But there are many structural specifications out there covering design and fabrication as well as the product standards. So you've generally got three different types: product standards, design standards, fabrication standards. And at the end of this in the appendices is a huge specification reference list. So everybody signed up for the presentation will be able to access that list and see where to be sort of signposted to. American and European specifications and their codes are the most widely used today, but the Chinese specifications are developing quickly, and there's a list of those as well in the appendices. So I'd now like to move on as we get towards the end to what I've termed modern thinking, illustrated by the statue of the thinker. So in terms of modern thinking, I'm going to be a little controversial here. Modern or forward-thinking people have been around for a long, long time. We probably know some of the people from a long time ago, but modern thinking ebbs and flows and becomes distorted by what I call money madness. And I'll start to illustrate this over the next few slides. But if we think about building a structure, do we genuinely consider what is best for the people that will use or benefit from that structure? And I think there's a number of issues here. Is the structure always going to be accessible? Is there a high reliability of all the features that the users require all the time? Is the building or structure always going to be safe? No deterioration of the public areas, the structural elements? Is fire safety correctly specified and defined? Is it addressed properly? Do we do these things to the best of our abilities? And do we make facilities inclusive? They're suitable for people with mobility challenges, for example. And I think we don't always do that. We don't get the best for our users because short-termism dominates. And I would argue that in many cases, the notion of creating something and using something are separated. So if you make something with low cost mentality, you won't get something that works well into the future. Now, moving forward and taking this notion into account, I'd like to sort of touch on the Schaffhausen Bridge in Switzerland. This was opened in the mid 1990s, so about 30 years ago. But for the construction of this bridge, life cycle thinking was at the heart of the development. Closing this bridge for maintenance would have created a massive problem for people moving around, for freight movements. So the bridge was designed fully with stainless steel reinforcement in, and the actual cost, because you could reduce other materials, was 12% lower than a traditional approach. So this is a fantastic case of stainless is not expensive. And over the 30 years that this bridge has existed, it's never been closed and no significant maintenance has been carried out. So this is a great case study to say, hey, once you start thinking differently, you can create something that ticks all the boxes. Now, I've touched on maintenance a number of times, and I would argue that for many companies, it's seen as a profitable activity, but in my head, that disrupts modern thinking. So, question, how many times, and ask yourself this question, do you find an elevator or an escalator not working somewhere? Yesterday, I saw 5 in the same building, which is staggering. 5 escalators not working in the same building. And have we accepted that this is just normal? I think it's not normal, it's abnormal. But have we normalised the consequences of maintenance, that disruptions to our daily activities, delays to travel, restricted access, increased costs, whether it be personal or for businesses, just happen? And I would say this is not the right way to think. If you choose resilient materials, you provide the opportunity to reduce or eliminate maintenance. So I think this is a start point of how we should think about things going forwards. And I'll illustrate this with Bush Lane House, which I talked about earlier. So as you now know, it's got a stainless steel exoskeleton, but the whole thing was driven by people had to have a view of St Paul's Cathedral as a fantastic and memorable structure in London. So the height was limited. So the need for internal columns was avoided. The fire protection was overcome by water cooling in the exoskeleton itself. And this was made out of stainless steel duplex grade 2205, which at the time was probably one of the most common duplex grades. And if you look at the project targets, all these things were achieved with a different way of thinking. So I think this is one great example. I'd also like to bring things a little more up to date with the Qingdao International Airport roof. Now, this is an inland location, 20 kilometres from the coastline. So you'd normally say, hey, what are the marine environment problems here? But the climate's not good. Strong and high winds, heavy rainfall, airborne chlorides meant that anything you built here was going to be attacked by chlorides unless you chose a metallic grade that was resistant to chlorides. And in this case, it was the ferritic stainless steel with 22% chromium and 2% molybdenum. Molybdenum resists pitting corrosion. And when you're choosing 1,000 tons of material, you want the right grade, of course, for a long design life. You don't want to be putting people on the roof of a building that suffers this unfavourable climate. So this was driven by the climate, but is a very smart use of stainless steel. If we look at the targets, it's an affordable metallic solution delivering the right level of corrosion. That was achieved. An elegant roof design and minimal maintenance. All those things achieved with an extensive use of stainless steel. Moving on, we've also got the Tokyo Haneda Airport in Japan. This goes back to 2010. And this was a runway being built out at sea. So you've got a marine location. And here, because of the sort of difficulty of accessing the structure below the runway deck, stainless steel cladding around structural steel was what was chosen. 500 tons in total, very highly alloyed grades to recognise the need for essentially no maintenance here. So this was a very interesting project, and again, perfect corrosion resistance demanded highly alloyed grades. Using the stainless steel as cladding allowed you to cut down the amount of stainless steel, so protection of the structural steel, and difficult access for a structure that you wanted to have a long life. So another great example of the selective use of stainless steel. And I'd finally, in this section, like to illustrate the Ava modular footbridge, which is a 100% stainless steel bridge made as a modular structure from flat stainless steel components that are formed into structural components. No welding, everything's bolted together. It's about, say, 70 tons of stainless steel per bridge compared to in excess of 100 tons for a more traditional materials bridge. And it comes in cheaper than the traditional bridges. Here, the benefits also include the elevator system, which are the most reliable in the world, with accessible and duplicated drive systems. So if the drive system or any element of it fails, the elevator still keeps working. The capex was 30% lower. You've got a timeless appeal that requires low maintenance and a guarantee of 120 years of operating life. So this is a tick all the boxes solution, which is fantastic. So, in summary, before we jump to questions, I would argue that stainless steel should be part of your built environment materials palette, both for the total replacement, as in the Ava bridge, or the partial replacement of your materials choices. When you're choosing stainless, you create the opportunity to better care for and safeguard our society. You're not going to have things that are going to fail. You deliver structural safety. You deliver asset longevity. You reduce life cycle costs and emissions. You're wedded to the circular economy. And of course, these things look amazing. And I would prefer that in the future, as a society, we're not learning a new song called the environmental blues, because we are choosing the right materials. We're striving for fit and forget rather than install and repair. And as Albert Einstein said, and I've littered this presentation with a few quotes from Albert, a clever person may well solve a problem, but a wise person uses the available resources to avoid the problem. So with that, I'd like to thank you for your attention and hand over to questions.
There is a question here. Any suitable recommendations for a stainless steel grade for railway applications? For instance, the railway track, the ballastless track slab, derailment curb, containment system.
Yeah, I think when you're looking at the track work for rail systems, I would say that stainless steels are not necessarily the right choice at all. I would not recommend them because you've many other considerations. And when you think about the ballasting and the sleepers, again, more suitable to concretes and aggregate material rather than stainless. I think for railways, you need to think about station structures and cladding on stations. I think you need to think about elevators carefully. And when you've got electrified overhead lines, I think their stainless has a place, but you don't need a high cost stainless. There are plenty of examples around the world where stainless steels have been used for the mounting frames for the catenary systems. And they tend to be lower cost stainless that will survive without any maintenance required for 100 years at least. So I think for rail applications, I'd be very careful. Bridges, because repairing bridges on a rail infrastructure is always a tricky process because you probably have to put scaffolding up. You can't run trains during the period. The time available to do repairs is usually short. So if you choose a material that doesn't demand maintenance for things going over railways, you'll do rather well. I think for stations, there's real opportunities, but for the track work, apart from catenary systems, uh, I'd not be pushing stainless. I think it would be bad advice from our industry. So that would be my response to that.
Thank you, Tim. Yes, we do. First question that came in is it says many of the structural applications you have highlighted include the use of flat stainless steel components. But can you also talk a bit about environments that require tube and pipe material?
Okay. So I've really not gone into tube and pipe much, and some people may say, "Hey, that's a bit of a sort of oversight." Tube and pipe does tend to be used, and wire, for more decorative features on structures. And there's quite an established and extensive use of those products. So I've deliberately not talked about them because I see the opportunity in the structural applications more so than what I'd call the decorative applications. So handrails are often made from tube. The wiring in fencing systems on the decks of bridges, as an example, is fairly frequently specified in stainless, and particularly if you're close to the sea or in an environment where chlorides are present, that's fairly common. So there is an extensive and established use for those products. I think when you're looking at structural products, you tend to want to look at solid things, not tube so much. But of course, the notion of cladding another material, i.e., a structural steel, you're essentially creating a tube, but it's just a big tube in that case. But it's probably formed on site and welded there rather than sort of made off site to fit around something. But of course, both options are possible. So there is a place for those products. But today was more about getting a concept across, if that makes sense. And I hope that answers the question.
I think you've gotten some concept across because we don't have more questions. Uh, so whether it's a good or a bad sign, I don't know. But certainly we can get more questions afterwards as well, can't we?
Of course, yes, if people want to dwell on the things I've said and ask questions after the event, that's fine. As I said at the start, everybody will get the presentation, and in the appendices, there's lots of helpful and supporting information. Of course, when you've only got something of the order of 45 minutes to speak, you can't get into every element in detail, but hopefully I've illustrated the possibilities well enough to give people an appetite to, if you're trying to sell stainless products, you've got some tools to help you. And if you're trying to consider using stainless products, you're more switched on and you'll think about stainless in a positive way. So I hope that all makes sense. And as I said, if you've got any questions that come up later when you've thought about this and digested the presentation, please don't hesitate to contact us. You can contact me directly at collins@worldstainless.org. Um, so, unless there's nothing else coming in, thank you very much, and I look forward to seeing you at future webinars in the near future. So, have a good day, take care, and think stainless, please.